Hi. So the submission that I got today was in regards to limits, specifically a calculus question. Now, the student that I had different questions, but I just brought these three up because I feel like these are going to be the most interesting to talk about. Um, so just as starters, what is a limit? The way that I like to explain it is like there's that saying where it's not about the destination, it's about the journey. Well, limits in this case are the journey, right? Essentially, what it is it's not talking about what's actually happening at the particular point rather than what's happening as we approach the point. So let's go talk about a specific instance in this case right here. Okay, so at the y equals f of x, right, the f of 1, at the point 2, the f of 2, if we were talking about that particular point, it'd be y equals negative 2. Why? Because there's technically a hole here, right? There's not necessarily anything here. However, a limit would be a little bit different because let's say, for example, if we were taking the limit from the right side, then the limit from the right side of as x is approaching 1 here is going to be 2. Why? It's because it's not doesn't really care about what's happening at this particular instance. It's only caring about what's happening as we are approaching that point. Again, very important. It's what's happening as we're approaching. Um, which is very confusing to people because all the way up until this point, we always talk about what's happening at the actual point. In this case, we don't care about that at all. We just care about what's happening as we're getting there. So down below, I have a few questions I wanted to get over or get through. This first one being the limit of the f of g of x as x is approaching negative 2. So this is a composite function, meaning that it's a function within a function. And the way that we do these is by working from the inside out. So the first thing we're going to do is the g of x as x is a negative 2. Okay, so I'm going to come over here to g of x. X is negative 2. What is my y value? 1. Okay, so now what I'm going to be doing is I'm going to be finding the limit of the f of x as x is what's happening when x is equal to 1. Okay, now a little bit of backstory about limits. Limits have to be converging at the same exact point from both sides. That's what makes it a limit. So if it's going to two separate places, usually, let me just like say that right now, usually that'd mean that the limit doesn't exist because it's got to converge on the same exact point. So the reason why I bring that up is because here, again, the g of x as x is approaching negative 2 is going to be equal to 1. So I come over here to the f of x graph, 1. Okay, I got 2 points, 2 and negative 2. Now, typically, this would mean it does not exist. However, I wanted to bring this up specifically in this video because this is actually a special case, and I'll explain why. The reason why this is a special case is because we have to look again, very important, at the behavior of the function as it's approaching the point. Notice that over here in the g of x, as it's approaching negative 2, we are coming from the positive side in both directions. So if I could rewrite this limit, let me just rewrite the limit over here. When I take the limit of the f of g of x after I find the point, let me just write this here. What changes is that now instead of having x is approaching negative 2, what I'm going to have is I'm going to have the g of x is approaching 1. But now that's why we have to really pay attention that with what's happening at the g of x as x is approaching 1, right? What's happening? Well, notice how it's converging from the top on both sides. So let me put this on a number line essentially. If I put this on a number line, let's just say this is 0, for example. This is 1. All of my values are coming from above. So they're coming in this direction, meaning that everything has to be coming from the positive direction, essentially changing this into a one-sided limit from the positive direction. The reason why is because everything's coming from one side, right? There's nothing coming from over here. All of my y values are bigger than my single y value here at 1. So it's a one-sided limit now. So that's the reason why this does not exist, is because technically we're not taking a limit anymore. We are taking a one-sided limit, which only cares about what is happening from one side of the point. So in this case, we only care about what's happening as we're approaching 1 from the positive side. So in that case, we're going to be coming from this direction, 1. So the answer here would be equal to 2. Okay, here's another example that's pretty similar to that. the limit of the g of f of x plus 1 as x is approaching 1. Okay, again, very important that we work from the inside out. So I'm going to plug in my 1 value. 1 plus 1 is 2. So I'm finding the f of 2. Okay, so I come over here to the f of x, f of 2. Okay, it's equal to 1. Okay, so now down here, I'm going to be finding the limit of the g of f of x plus 1 as now the f of x is approaching the value 2. Okay, so now this is how it's rewritten. So now I come over to the g of x. I look at my value. Well, let's see what happens at the f of x as it's approaching 2, actually. So it's approaching 2 at 1. So I come over to the g of x. I find where 1's at. Cool, right here. Same situation again. Technically, if this was a normal situation, this would not exist because it's converging on 2 different points from both sides. However, again, the same idea. Notice that the limit in this case is getting approached from the positive direction on both sides. So it's kind of the same situation as we had over here. This is going to basically become a one-sided limit from the right side again, because all that's happening as we're approaching this point of 1 is positive numbers, right? There is no negative numbers. So we can't approach the limit from the negative side because it's not physically happening. Everything's from the positive side. It makes it a one-sided limit. So in this case, I look in the positive direction. So in this case, the answer would be equal to -1. Okay, that brings us to our final question. The limit of the g of f of x as x is approaching -2 from the left side, right? That's what this little value here means. It's just from the left or from the right side. Left side's negative because those are all the negative values over here. Right side's positive. All the bigger values are over here. Okay, so then what I do, come to my f of x, find -2. From the left side, it's approaching 1. Okay, so now I come over here, x is equal to 1, and I have the same situation here. Okay, now how do I solve this one? Well, again, I have to focus on what is happening with the behavior as we're approaching this point. Again, I got to drive this home. Limit is all about the journey. The journey, not the destination. What is happening along our way to 1? Well, we're coming from negative numbers, right? We're coming from below, which means that when I find my value over here, I have to also come from negative numbers, right? I have to come from the left side. So in this case here, I got these 2 values. Is it going to be 1 or is it going to be -1? Well, in this case, it's going to be 1, right? Because I'm coming from the left side. I'm coming from the left side. I'm coming from the negative side over here, which is going to ultimately make this equal 1, finishing it out. So again, in conclusion, the most important thing about limits is it's all about the journey, not about the destination, right? It's what we're doing as we're approaching the particular point, not what's happening at the particular point itself. So if we're approaching from the positive direction on our way down, then we only care about the positive direction that we're approaching on when we find the limit. Same thing, vice versa. If we're approaching from the bottom from below each time, then I'm going to be taking a one-sided limit from the left side. The reason why is because all the values approaching are coming from below. It's all y values that are negative. So when I come over here to my composite function, I got to look at all the negative values that are approaching that point as well. Okay, that is the most important thing when it comes to limits. Really recognizing the behavior of the graph as it is approaching that particular point. As long as you understand that, you'll be good. All right, take care.